All right, guys. Tonight's homework is all no calculator. So it's my dog barking. So what we're going to do is look at all these different types of log equations and try to remember all the steps for solving. Okay. So the first one is log base 10 of 3z equals 2. If it's a log equation and you've already got the log isolated, you base both sides. In this case, I'm going to base 10 both sides. 10 to the log base 10 cancels out. You're left with 3z equals 10 to the second power, 100, and z equals 100 over 3. As long as the answer you get gives you a positive value inside of the logarithm, 3 times 100 over 3 is positive, then that is your answer. Okay, take a look at 64. This one is a natural log equation. There's just a single natural log. So we need to isolate that first. We need to isolate that first. So we need to subtract 3. 8 ln x is equal to 4. And then we need to divide by 8. So ln x is equal to 4 divided by 8, which is 1/2. This is a natural log, so to get rid of the natural log, we base e both sides. The e and the natural log cancel out. I'm left with x equals e to the 1/2. You could also make that square root of e. It's all the same thing. Right, number 72. The natural log is already isolated, so we're going to base e both sides. E to the natural log cancels out, so it's square root of x minus 8 equals e to the 5th. I need to square both sides to get rid of the square root. So now it's x minus 8 equals e to the 10th because I multiply my exponents. And then we add 8. So e to the 10th plus 8 gives me my value there. All right, this next one. Now, there are 2 ways to go about this one. You could take this exponent and put it out in front here. So we have 2 ln x minus 4 equals 5. And then I can divide by 2. And then I can base e both sides. So that leaves me with x minus 4 equals e to the 5 over 2. There's an extra mark there, sorry. And then we can add 4. Now, I did say there are 2 ways to solve this equation. So maybe you didn't think to expand this out. So if you left it as ln of x minus 4 squared equals 5, this is okay as well. You can still base e both sides. And then you get x minus 4 squared equals e to the 5th. So in this version, I have to square root both sides. And I still get to x minus 4 equals the square root of e to the 5th. That's the same as e to the 5/2. And so you get to the same answer. For number 85, when I have 2 natural logs in an equation, I need to condense first because I can't just move a natural log to the other side if there's another number over here. So condense this. This is the natural log of x divided by x plus 1 because we had subtraction of natural logs here. Now that I've got the natural log isolated, I can base e both sides. So x over x plus 1 equals e squared. Now I need to solve this rational equation. I can multiply the x plus 1 over to this side. And when you do that, you would get e squared x plus e squared. I distributed that because I want to solve for x, and x is still in 2 places in this equation. So you need to get rid of the parentheses. And then any term that has an x needs to get moved to the same side. So x minus e squared times x equals e squared. And when we run into this scenario, which we do a lot for these types of problems, log equations and exponential equations, the way to solve for x is to factor an x out because it's a GCF. That leaves you with 1 minus e squared. By factoring x out, you've now allowed yourself to isolate x because you can divide by the parentheses. So x equals e squared divided by 1 minus e squared. Remember, we have to leave our answer like that. It is illegal to make it e squared over 1 minus e squared over e squared. That is an upside down heart. You can't do that. Okay, so get that out of there. So don't do that. Just leave it here. If this were flipped upside down, then I could say 1 over e squared minus e squared over e squared, but you can't do it. You can't divide a monomial by separating the binomial. Okay, for 86, same idea, but now I'm adding the logarithms. So we need to make this the natural log of x times x plus 1. So x squared plus x. And then I base e both sides to get rid of the natural log. X squared plus x equals e to the first. Now this is a quadratic equation. Remember, e is a constant. It's like 2.7-ish. So we can still solve any quadratic as long as we get it equal to 0 first. And we can use the quadratic formula. We have to use the quadratic formula. It's not just like, oh, I can't solve this. All right, so opposite of b plus or minus square root of b squared minus 4 times a times c over 2 times a. The question is this a real number or not? And you do get, let me work on this a bit. You get the square root of 1 plus 4e, which can't be combined. But that is a positive value underneath my square root. So this is the answer I get for x. All right, take a look at 87. There are 3 natural logs in this problem. The side that has multiple natural logs needs to get condensed. So I'm going to leave the left side alone. So the natural log of x plus 5 equals the natural log of x minus 1 over x plus 1. Now this is kind of a one-to-one property. If the natural log of this side equals the natural log of this side, then really all I need to do is set their results equal to each other. Another way to think of this is you can still say I'm going to base e both sides. Either way, you just get their results equal to each other. This is another rational equation like we solved in chapter 2. And if I just have a single denominator, I can just multiply it to the other side. So x plus 1 times x plus 5 is equal to x minus 1. So x squared plus 6x plus 5 equals x minus 1. This is quadratic again, so get it equal to 0. X squared plus 5x plus 6 equals 0. Oh, this just made me think about something with that last answer. We'll come back to that last answer in a second. Let's factor this. So I need the factors of 6 that add or subtract to 5. It's got to be 3 and 2. I can't choose 6 and 1 because I would have to have plus 6 minus 1, and that would multiply to negative 6, not positive. All right, now I get 2 negative answers. And remember, we can't log negatives. However, if any of these answers cause us to have a positive expression, then for everything, then it's okay. So if I plug in negative 3, ln of negative 3 plus 5 is ln of 2. So that's fine. Ln of negative 3 minus 1, that's no good. That's ln of negative 4. So I can't use negative 3. And actually, similarly, I can't use negative 2 because of this x minus 1. So both of the solutions I got are actually extraneous solutions. And so this is no solution. All right, so kind of strange for that one. Now, why did I say, oh, wait, what about this one? So remember, we can't log negatives. So negative 1 plus the square root of 1 plus something, 1 plus something is definitely, the square root of that is definitely bigger than 1. So the positive is positive, but negative 1 minus that is negative. So actually, I need to unbox this. throw out the negative. And so my only solution is -1 plus the square root of 1 plus 4e all over 2. So I'm not expecting you to know what decimal approximation the square root of 1 plus 4e is, but I do expect you to understand that the square root of 1 plus 4e is greater than the square root of 1, right? Because we're adding that value. So it's definitely bigger than 1. So when I add this, I do get a positive numerator. Okay, take a look at 91. There are 2 logs and a fraction over here. We want the logs to stay together, but we need to move the non-log to the other side. So let's condense these 2 logs. This time it's the log base 9 of x squared plus 2x. And instead of equaling 0, it equals positive 1/2. And then we can base 9 both sides. So x squared plus 2x equals 9 to the 1/2. Remember, 9 to the 1/2 is the square root of 9, so that's 3. This is quadratic, so get it equal to 0. And factor. We love when things factor, right? So I'm getting -3 and positive 1. Now, -3, when you plug back into log of 9, log base 9 of -3, that's no good. You can't log a negative. Same with -3 plus 2, that's still negative. 1 is okay, though. The log, we can take the log of 1, we can take the log of 1 plus 2. So 1 is the only solution. 116 and 118 are similar types of problems. So now we're doing exponential problems for these two. So we're kind of switching gears. All right, so let's look at what we have here. A pretty complicated looking expression. So an x is in both places. So my first thing to think about is, can I factor this? So what is the greatest common factor? Well, they both have e to the negative x. So we're definitely factoring that out. And then we have a negative x squared and a positive 2x. So you can take out an x or a negative x. It's up to you. I'm just going to take out an x. So what would that leave us with? If I divide this term by x, I'm left with negative x. If I divide it by e to the negative x, those cancel. If I divide 2x by x, I get plus 2, and we're taking the e to the negative x out. All right, and then we set both parts equal to 0. E to the negative x times x equals 0. Now, e to the negative x is never 0, right? It's the same as saying like this. So if I multiply that to that side, I only get x equals 0, not because of the e at all, but just because of the x out here. And then over here, if negative x plus 2 equals 0, then add x over x equals 2. This is an exponential equation, so we are not throwing out the 0, or I don't have a negative, but all answers are valid for this problem. We'd only get extraneous solutions if it was a natural log equation. All right, so let's take a look at 118. So again, I have x's all over the place in the exponents and down here. So this is a factoring problem because I can't simply isolate x or isolate the e. So factor out e to the negative 2x because they both have that. And I can't factor out an x on this one. If you divide e to the negative 2x by itself, you get 1. If you divide the next term by e to the negative 2x, you get minus 2x. Again, e to the negative 2x is never equal to 0. It's 1 over e to the 2x. We talked about this way back in the beginning of the year with domain and range problems. If there's no x in the numerator, there's no way this fraction can equal exactly 0. It can get very close to 0 as x gets huge, but it's not going to equal 0. If 1 minus 2x equals 0, then negative 2x equals negative 1, x equals positive 1/2. And again, I don't even have to check that answer for it to be extraneous. There are no extraneous solutions in exponential equations. All right. Oh, these are our last two. So now we're back to natural log equations again. And I need to think about this and say, all right, this is kind of a rational equation to start. So when is a fraction equal to 0? It's really just when the numerator is equal to 0. I can multiply the x squared over here. So I'm really just looking at when is 1 minus ln x equal to 0. Here's what I need to keep in mind. X squared can't equal 0 because then we would be dividing the original. So if I get 0 as an answer, I cannot use it. Same for any negative value because of the natural log. All right, so I'm going to add ln x to the other side. Base e both sides. E equals x. E is not 0, so that's okay. All right, what about this one? There are x's all over the place and an ln here. So, and remember, we can't condense because this is not a natural log. I can do a little bit of factoring out, though. I can take out, this is a term and this is a term. So I can factor out an x, and that would leave me with 3 ln 1 over x minus 1 equals 0. All right, so from the outside, I get x equals 0. From this, I need to isolate the natural log by adding 1 and dividing by 3. I could expand this out, ln of 1 minus ln of x. I'm just going to go ahead and base e both sides, though. I don't think it's going to be too bad. I don't know. Maybe this would have been better. I'll do it both ways. This gives me 1 over x equals e to the 1/3, or cube root of e. I need to solve for x. Right now it's in the denominator, so I'm going to multiply it to this side. And then I'm going to turn around and divide by e to the 1/3. That answer is positive, so I don't have to worry about throwing it out. X equals 0 is extraneous because I can't do ln of 1 over 0. That's undefined. Okay. What if I would have separated this out? So ln of 1 over x equals 1/3. That's what I had. So what if I expand it? Ln of 1 is 0. So now it's negative ln of x equals 1/3. Before you base e both sides, you have to get the negative to the other side. And then you can base e both sides. And yeah, you get to the same answer because e to the negative 1/3 is 1 over e to the 1/3. So cool, you can do it either way. All right, these equations, the hardest part is when you bounce back and forth and you're trying to figure out, like, what are my first steps? So a good study skill on this is to list out the different types of equations we have. Like, go back through. Is it 1 log? Is it 2 logs? Is it 3 logs? Is it 2 logs in a number? Is it factoring? So go through and list the types of problems you have and write out the steps for yourself. Like, what are you supposed to do first? What's the next step after that? Study the steps for these problems besides just practicing doing the math.